Newton's third law. For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there is a pair of forces acting on those two interacting objects. Newton defined 3 laws of motion that all play important roles in space exploration. The first states that every object in a state of uniform motion will remain in that state of motion unless an external force acts on it, like the American flag on the moon, frozen in the same position forever due to the lack of force. This law also means that if we jump up in the air, we would simply continue to travel up and up and up, were it not for the external force of gravity. Force equals mass times acceleration is the second law. And as stated above, for every action there is an equal and opposite reaction. The third one is the one we will focus on today. This law has much to do when it comes to rocket propulsion and escaping the atmosphere. Let's consult an expert.
We can see this happen when there's an object dropped on a table. The object exerts a force down on the table, and the table exerts an upward force on the object. There's an action force and a reaction force. Same magnitudes, but in opposite directions. They're equal, just opposite. With rockets, fuel, which starts off as a liquid, combusts and turns to a gaseous state. Combustion forces the gas to expand and forces it downward, which creates a thrust. Hopefully that creates enough thrust to force the rocket upward and eventually into orbit. One fun fact is that, believe it or not, lighter fuels perform better than heavy fuels because they're easier to force downward, therefore creating a stronger downward force. The NASA Enterprise, which was first introduced in 1976, weighed roughly 4.4 million pounds at launch. That requires an insane amount of downward force to get it off the ground. The good thing is, most of the weight is fuel to force the other 165,000 pounds of the shuttle into orbit.
And just like that, we can get massive rockets into space, in orbit, to the moon, to Mars, and hopefully further. Well, it's not that simple, as there are more calculations than most of us could imagine going into a rocket launch. But now hopefully, you and me both understand the basic principle of equal and opposite forces a little bit better. Thank you.